Using linear inequalities in one variable to make predictions. Addition property of inequalities. If A is less than B, then A plus C is less than B plus C. Similar properties hold for less than or equal to, greater than, and greater than or equal to. What this means is I can have an inequality like x plus 3 is less than 8, and I can subtract 3 from both sides. X plus 3 minus 3 less than 8 minus 3, and the inequality is still correct. My result is x is less than 5. Multiplication property of inequalities. For a positive number c, if a is less than b, then a times c is less than b times c. For a negative number c, if a is less than b, then a times c is greater than b times c. Similar properties hold for less than or equal to, greater than, and greater than or equal to. In words, when we multiply both sides of an inequality by a positive number, we keep the inequality symbol. When we multiply by a negative number, we reverse the inequality symbol. Given an equation such as 2/3 x less than 6, I can multiply both sides by 3 over 2. 3 over 2 times 2/3 x less than 3 over 2 times 6, and I still have a true statement. My result is x is less than 9. If our 2/3 was negative, such as negative 2/3 x less than 6, when I multiply both sides by negative 3 over 2, it's going to also change my inequality symbol. Negative 3 over 2 times negative 2/3 x is now greater than negative 3 over 2 times 6. We're going from a positive value of 6 to a negative value for our answer, so it's going to change the direction of our inequality. The result, x is greater than negative 9. Using linear inequalities in one variable to make predictions. A linear inequality in one variable is an inequality that can be put into one of the forms: mx plus b less than 0, mx plus b less than or equal to 0, mx plus b greater than 0, mx plus b greater than or equal to 0, where m and b are constants and m does not equal 0. Solution of an inequality in one variable. We say a number is a solution of an inequality in one variable if it satisfies the inequality. The solution set of an inequality is the set of all solutions of the inequality. We solve an inequality by finding its solution set. Linear inequalities. The answer for inequalities are written in a different manner than the answers for equalities. In words, numbers less than 2 will be written as x less than 2 with the point towards the x. The graph will have an open dot at 2 and be shaded to the left. With interval notation, we always use a parenthesis for less than or greater than and a bracket for less than or equal to or greater than or equal to. Since we have an open dot, we'll be using a parenthesis. You always write the interval notation as it is graphed from left to right. Since we have an arrow pointing to the left, it starts with negative infinity and stops with 2. So our solution, written in interval notation, is parentheses, negative infinity, comma 2, close parentheses. Numbers less than or equal to 2 are written as an inequality with the less than or equal to symbol where the point is towards the x and we have a line. That means on our graph, the dot will be solid over 2. We're still shading to the left. The interval notation still starts with negative infinity, so we have open parenthesis, negative infinity, comma 2. This time we have a bracket at the end. Numbers greater than 2 are written as an inequality with x is greater than 2, where the point of the inequality is now towards the 2. There's an open dot at 2, and we shade to the right. Reading it from left to right, our answer begins just beyond 2 and goes on forever towards the right, with our numbers getting increasingly larger. So with our interval notation, we have an open parenthesis 2, comma, infinity, close parenthesis. Our infinity is on the right because we're shading to the right. Our numbers are positive, so my infinity is positive. Numbers greater than or equal to 2. X is greater than or equal to 2 with the point towards the 2 and a line under your inequality symbol. For our graph, the dot is filled in, but we're still shading to the right. With the interval notation, we have a bracket, 2, comma, infinity, close parenthesis. In this example, use a symbolic method to solve the inequality. Describe the solution set as an inequality in interval notation and in a graph. The inequality is x plus 4 greater than or equal to 7. Subtracting 4 from both sides, my result, x greater than or equal to 3. Next, I want to graph my inequality by finding 3 on my number line. Using a solid dot, because it's greater than, I'm going to shade to the right, using an arrow at the end to show it goes on forever in that direction. Reading my graph from left to right, I begin with 3, and it's a solid dot. So for interval notation, I have bracket, 3, comma, because it's shaded to the right, we use a positive infinity, close parenthesis. In this example, the inequality is negative 3x less than 18. Use the symbolic method to solve the inequality. I want to divide both sides by negative 3. My result, x is greater than negative 6. Describing the solution set in a graph, I want an open dot at negative 6, then shade to the right. Writing my answer in interval notation, start with parenthesis, negative 6, comma, positive infinity, close parenthesis. In this example, my inequality is 6x plus 2 less than negative 10. Using the symbolic method to solve the inequality, subtract 2 from both sides. 6x is less than negative 12. Divide both sides by 6. X is less than negative 2. Graphing my inequality, I want an open dot at negative 2. And this time, since it's less than, I'm shading to the left. Writing my answer in interval notation, since it's shaded to the left, I begin with negative infinity, comma, negative 2, close parenthesis because it's less than. 3-part inequalities. In words, numbers between 1 and 3 is expressed as an inequality as 1 less than x less than 3. For the graph, we have an open dot at 1, an open dot at 3, and the line goes between 1 and 3. For interval notation, we have parenthesis 1, comma 3, close parenthesis. Numbers between 1 and 3 inclusive. The inequality would be 1 less than or equal to x less than or equal to 3. For the graph, we have solid dots for 1 and 3, and we still graph between the dots. For the interval notation, we have bracket 1, comma, 3, close bracket. For numbers between 1 and 3, as well as 1, we only have the or equal to on the left side. 1 less than or equal to x less than 3. For the graph, only the 1 has a solid dot, the 3 has an open dot, and we still shade between the two numbers. For the interval notation, we have a bracket, 1, comma, 3, parenthesis. In words, numbers between 1 and 3 as well as 3, this time equal to is on the right. The inequality is 1 less than x less than or equal to 3. 1 has an open dot and 3 has a closed dot with the shading between the 1 and 3. In the interval notation, we have a parenthesis, then 1, comma, 3, bracket. In this example, we want to use the symbolic method to solve the inequality. Describe the solution set as an inequality in interval notation and in a graph. The inequality is -1 less than or equal to 3x minus 7 less than or equal to 5. For this example, we still want to isolate the x. However, when we add 7, we're actually going to add the 7 to 3 sides. -1 plus 7 is 6, less than or equal to 3x, less than or equal to 5 plus 7, which is 12. Then we want to divide everything by 3. Our result is 2 less than or equal to x less than or equal to 4. When we graph the inequality, we want a solid dot at 2, a solid dot at 4, then we'll shade between 2 and 4. For the interval notation, we have bracket, 2, comma, 4, close bracket. In this example, the inequality is 2 less than 8 minus 2x less than 10. We have the same directions, so the first step is to subtract 8 from all three sides. -6 less than -2x less than 2. Now we want to divide everything by -2, so the result is 3 greater than x greater than -1. This is the same as writing -1 less than x less than 3. It's going to be a little easier to graph if we rewrite it. That gives us an open dot at -1, an open dot at 3, and then we shade between. Our interval notation would be parenthesis, -1, comma 3, parenthesis. In this example, we're going to have a model for our inequality. One budget office rents pickup trucks for $39.95 per day, plus 19 cents per mile. One U-Haul location charges $19.95 per day, plus 48 cents per mile. Sources, budget, U-Haul. Find the models that describe the one-day cost of renting a pickup truck for the companies. Let B of D be the one-day cost in dollars of driving in a budget pickup truck, D miles, and let U of D be the one-day cost in dollars of driving a U-Haul pickup truck, D miles. Starting with budget, We want to use y equals mx plus b for our model. Our y-intercept b is 39.95, since that's what we start with. Our slope is 0.19, since this is how much is charged for each additional mile. B of D equals 0.19D plus 39.95. For U-Haul, it charges $19.95 per day, so that's going to be our y-intercept. Then they charge 48 cents per mile. That's going to be our slope. So U-Haul is U of D equals 0.48D plus 19.95. Use the graph of your models to estimate for which mileages budget offers the lower price. The two lines cross at 66.7 and 52.6. What this means is that the price for U-Haul and budget are the same at that dot. So if we drive 66.7 miles, then both U-Haul and budget will cost $52.60. To the left of that dot, our red line is lower than our blue line. That means that the cost of U-Haul is going to be less than the cost of budget. After that dot, the blue line is lower than the red line. So at that point, budget is going to be less than U-Haul. So any mileage that is greater than 66.7, budget will have the lower price. So D is greater than or equal to, so D is greater than 66.7. In this example, the model for U.S. advertising and billions of dollars in magazines and the internet is given by the systems. Magazines: A equals F of T equals 0.4T plus 11.8. Internet: A equals G of T equals 2.8T plus 6.6, where T is the number of years since 2003. Estimate in which years U.S. advertising in magazines was less than U.S. advertising in the internet. For this, we want to go to our calculator. To graph our functions, go to y equals. I'm going to start with the function for the magazine, 0.4t. Remember, our variable will always come up x, no matter what our variable is in our model, plus 11.8. Enter 2.8 and our variable plus 6.6, and that's our internet equation. And now we're ready to graph them. I go to Zoom. So in Zoom, we're really interested in the first quadrant, which is A. Enter. And we have our lines and we can see where they cross. We have a little trouble seeing them. It would be better if we had more of the y-axis showing. I'm going to go to Window. We had a little too much of the x-axis showing, so I'm going to reduce that to 5. And then for my y-max, let's increase that to 20 and press Graph. So the blue line here is our magazine and the green line is the internet. And we want to find when the U.S. advertising in magazines was less than U.S. advertising in the internet. First, let's figure out where exactly it is that they cross. For that, you have to see where they crossed in your window, then go to Second, Trace, which is your calc. We want intersect, enter, and then enter, 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 and it gives us the intersection using 1 decimal place. X is 2.2 and Y is 12.7. Now we need to figure out when the advertising in magazine was less than the advertising in the internet. The magazine line would have to be lower than the internet. Our magazine line was blue, so it is lower to the right of where they cross. So our answer, T, is greater than 2.2. Using linear inequalities in one variable to make predictions. With linear inequalities, we can solve them just like equalities by adding something to both sides and it stays an inequality. If we have a positive number, we can multiply or divide something to each side of the inequality and it stays a true inequality. If we multiply or divide by a negative number, it flips your inequality sign. We can write our solution set of an inequality as an inequality, such as x is less than 2, in interval notation using positive or negative infinity, parentheses and brackets, and as a graph. We use an open dot for less than or greater than, and a closed dot for less than or equal to or greater than or equal to. Then we shade in the appropriate direction. We can also use inequalities to make predictions about models. Once we graph the inequality, we find where they cross, then we can make decisions about which has a lower revenue versus a higher revenue.